So what I want to do is to give a brief outline of the strategic innovation program for aeronautics in Sweden. Some slides I will go through pretty quickly, but we will put this presentation on the home page, and the address of that you can see on the first slide. We have one version in Swedish, and if you add the /en, there is an English version available. So as Hanna already mentioned, Sweden has a fairly unique position in aeronautics related to the small population. As you know, we are 0.13% of the world's population, and considering that, we have a fairly unique position in aeronautics. The reason we have that is, of course, a military background, that being outside of any political collaboration with other nations, we wanted to have a strong Swedish competence in military aeronautics. And on the military side, both on airframes, which I show here, and engines, we have a history of very large innovation. I don't need to dwell on this, but there are a number of unique events which took place in Sweden. All the actors came together for the first time in 2010, decided that we needed to join forces and write a first national research in innovation agenda for Aeronautics 2010. This can again be downloaded from our homepage. We updated that in 2013 to the document you see on this slide, again available on the homepage. And what was unique was that all the actors came together. Of course, the large industry, which in Sweden is Saab and JKN, previously Volvo Aero Engines. We also have academia involved, all the universities and the institutes working on related issues, and also governmental authorities like the Armed Forces, the Material Defense Procurement Agency, and representatives from funding agencies like Vinnova, of course. And on this slide, I have shown the present statistics. We have today more than 12,000 employees in the aeronautics area in the country, and the turnover is more than 20 billion Swedish crown every year. That value has more than 70% on export. However, the SME part is fairly small today. It's only 500 million, so roughly 2.5%. But we have a long-term strategy for 2050, where we have decided that the turnover should double to at least 40 billion per year, and we should increase the export value to 90%. At the same time, we want to make sure that we at least multiply the turnover for SMEs with a factor of 5, up to 2.5 billion. This, I think, is very realistic, and today's activity will be a key issue to achieve this when we have a much more strategic way to help small and medium enterprises to find their position, not only in Sweden, but in the global arena. This is just one slide showing a number of strategic partners to the two big industries I already mentioned. And as can be seen here, there is no wonder that many of these are located in this area where JKN is in Trollhättan. The entire western part of Sweden is the industrial center of Sweden. And this is one of the regions being here today. And the other region is, of course, up here at Linköping, where Saab is located. That's normal. But as you can see, Sweden is a big country. It's roughly the same size of France, but the population is somewhat smaller and basically down here. But we are making sure to include everybody. This activity is open for all the actors, irrespective of location. In this document I showed, we have, of course, a number of technical issues being discussed, but basically we can summarize the strategies into 4 areas. Number 1, on what should we focus Swedish aerospace research and development in the near future? And the answer is demonstrator activities, because that has been too little funded historically in this country, and it's a very important bridge from academic research into industrial activities. It's frequently called the valley of death in innovation discussions. So that is a major aim for us, both on the civil and military side. Second question is, how do we bring about the best possible conditions for domestic production? That is to making sure that we can design, produce, and manufacture components, parts, and systems in this country. And to strengthen this, we have started to build up 2 arenas for production, one on advanced metals and their production technologies in Trollhättan, and the other one advanced composites and their production technologies in Linköping. These are national resources, so they are located close to industry but can be used by all actors in the country. Third question is, how can academia best work to encourage innovation? What we want to do is to strengthen the research network and make that a seamless part of the innovation program, such that academic research will have higher impact in terms of industrial meaning. And finally, how do we secure consensus for and governance of the Swedish aerospace sector? And that is achieved by the establishment of Innovair as a coordinating body. Showing that this works, an example from JKN, we have the TLR scale and the slanted wave showing time. You can then see that today we are 2016, so we have engines being sold on the international market, but we are also at the same time producing next generation engines. That takes place at TRL 5 to 6. Otherwise, the technology is not mature enough to get into production. And at low TRL, we are also, of course, making research today, but that will be used in the generation after next. So at any moment, we need to be at 3 levels on the TRL scale. Something to be sold today, otherwise there is no money. The next generation, demonstrator activities, and research for the long term. And you can backtrack this, of course, to see that today's engines are derived on research taking place 15, 20 years ago. And if we summarize these values, you can see that JKN has achieved orders of 186 billion Swedish crowns due to this strategic plan with basic national research, basic international research on the European level, national demonstrators, and international demonstrators as Clean Sky. Examples from JKN, which are recent, being produced for Clean Sky, include what you see on the left-hand side. The top part structure is from JKN. It's a turbine structure being mounted on an MTU engine. And this structure can operate at much higher temperatures than previously, which is very beneficial. On the right-hand side, you can see a composite fan structure where the vanes are made of composite instead of metals. And this led to a reduction of weight with 30%. And weight, of course, will mean less fuel consumption and therefore less pollution. CO2 is proportional to engine consumption, fuel consumption. JKN, of course, is not working alone. As I said, they are having very strong ties to this production center, PTC Innovatum, we call it, in Trollhättan. This is again open for everybody, the big industries, SMEs, academia, and research institutes. Some of the excellence at this center include flexible industrial automation, metal cutting, additive manufacturing, thermal spraying, and welding. And these centers now, we have a strategic program focusing on SME development. So the SMEs get help from these centers to increase quality levels and so forth, such that SMEs can become qualified suppliers to the aeronautical arena. After having taken that step, they can get out into the international level, such as Clean Sky. Saab, same story. We have the same TRL versus slanted wave chart, showing that we have all these steps, national and international research programs, national and international demonstrators. Saab, of course, works very much on the military side, but are also producing civil technology, such as remote tower systems for air transport management, and also production of airframes, such as this, which is a fairly unique component. It's the integrated wing leading edge and upper wing cover, produced in carbon fiber reinforced composites for a project called BLADE, Breakthrough Laminar Aircraft Demonstrator in Europe. It's a flight demonstrator and is part of the smart fixed wing aircraft within Clean Sky. The unique thing with this is it's a very large structure. It's 7 times 3 meter made in one structure. And the problem is, of course, that the curing of the composite takes place at elevated temperature. And you need to control the deformation such that the final stage get exactly the right geometry is very, very sensitive. Otherwise, you cannot achieve laminar flow conditions. And Airbus has stated that this is the most advanced and integrated wing upper cover ever produced so far in the world. Again, Saab does not work alone, but they are working with the composite arena called Compressor in Linköping, and this is an example of cooperation for the next generation lightweight structures for cargo doors, which is part of Clean Sky. And also Compressor are working very closely with small and medium enterprises, trying to develop them to qualified suppliers for the aeronautics arena. So thank you so much. That's what I wanted to say.